unit from this example. Here is a hub node example. Okay, a hub node is the very simplest one where we've got a bunch of client equipment. We've got a bunch of SONET gear, in other words, and we have Gigabit Ethernet and SONET OC3s, OC12s, and OC48s, and maybe some digital video coming in and going out. And basically what we're doing is we're adding those using multiplexers. The client equipment includes all of those cards from Chapter 11, which turns the client signals into DWDM signals. And then it takes those DWDM signals, multiplexes them, puts them through a booster amplifier, and sends them on their way towards the east. It also accepts inputs from the east, gives an optical preamplifier with dispersion compensation, demuxes them for the clients. Okay, same thing on the west side. Okay, and the whole thing with the optical supervisory channel being pulled off and then put back on is all the same here. But this is a hub node where we've got a lot of client equipment here, which is connecting to probably lots of office buildings and that sort of thing. Okay. This chapter also includes how to make a mesh node, and this is a single piece of a mesh network created out of a ring that each has a 40-channel wavelength cross-connect optical add-drop multiplexing node added. So this one that we showed here with the ROADM, this is what is at each of those 4 spots around this ring. Okay, and this enables you to create a mesh network when you add and drop channels and move them over to some other wavelength cross-connect switches. They're not giving you a lot of detail here, but just to show you, they have these types of diagrams in this channel, in this chapter. They also, in this chapter, show you the rack with the fiber connections shown. So not only do they show you these sort of block diagrams with multiple optical units on them showing how they're connected together, they actually show them in the rack with the connections that they recommend to hook them up properly. So for example, let's see if we can follow this through. We've got an input on this side, okay, coming in here, okay, and this is going into the optical boost amplifier. Optical BST. Oh, that's the output. I'm sorry. Here's, well, I can't follow it through here. Why wouldn't it go to the pre first? Yikes. Very complicated. Well, don't worry about it. Basically, I just wanted to show you that they do show you these sort of wiring diagrams. Okay. They also show you that you can configure a node with multiple shelves. Okay. And this is a nice picture because it sort of points out the fact that there's a heck of a lot of client equipment associated with a single DWDM transponder node or shelf here. Here we've got a DWDM shelf. It's got lots of wavelengths. Each one of those wavelengths holds many, many multiplexed client signals, and you can see we have a single shelf with DWDM equipment in it, and we have a whole bunch of shelves with the TXP MXPs in them. These are all those cards from Chapter 11. Okay, these are the cards that are taking client signals and interfacing them to the DWDM shelf. Okay, and so This is just showing you that there can be a tremendous amount of client equipment associated with a single DWDM shelf. Okay, and that's because we've multiplexed so many signals into these ultra-high bit rate fiber channels. Okay, along with these multi-shelf node configurations here, they say that in section 12.4.1 that multi-shelf configurations are configured using the Transport Planner. This is a software which interfaces with the command and control software for the whole thing and allows you to plan out your network, essentially, and it allows you to manage the network. So, for example, as you get more customers at a particular office building, a new customer may need a particular wavelength to be provisioned for them, and this Transport Planner software helps you do that. It helps you configure the network initially, and it also helps you manage it. Here's an example of a screenshot, I guess, more or less, from that software, Transport Controller software. So it shows the shelves, it shows all the information about those channels on those cards in those shelves. Okay, it's very comprehensive software that probably takes years to figure out how to use. As part of the software, it shows you block diagrams like this that show you the different cards and how they're hooked together. This goes hand in hand with the picture of how to hook them together actually in the shelf with all of these wires showing. It shows you how to hook the fibers from one card to the other. And finally, the software takes you all the way up to a view showing the entire network. And this is sort of a typical little picture here where we've got 3 nodes in 3 widely separated spaces, and you can start all the way up at this level with this software and drill all the way down to individual nodes, individual shelves on individual nodes, individual shelves and individual cards, individual breakouts of multiplexed signals on individual cards. And so this sort of wraps up the summary that I'd like to give of the ONS system. We've gone through a lot of cards types, and we've related it back